Hello children, welcome. Computer Science, Cambridge O-Level, Theory, Section 1. Our lesson today is number systems. But before we start with any other number systems, like we have mentioned over here, binary number system, let us talk about number systems. Why we wanted number systems and why are we using these number systems and what actually we meant by number systems. Because whenever we say number system, it doesn't give any meaning at all for the time being. Let's see what are those number systems. As humans, when we were evolving throughout the generations, the humans wanted to count so many things, so many number of items, maybe even days they wanted to count. Okay, the sun is setting and there is going to be another day. So how many days have passed by? Those are few examples that the people wanted to count. So whenever they wanted to count something, they were initially using body parts. Body parts in the sense fingers, or they might have added toes later on. But when these fingers were not enough to count things that they had, they were even using some other methods. So let me write them down for you. Counting methods those people were using. Initially, it was fingers, the body parts. Then, the other methods that they were using, such as stones. They collected a heap of stones and they started counting them one by one to denote the numbers that they wanted. Stones, as well as those who couldn't find stones, they were using sticks. So they were using so many other methods to do this counting. Now, after some time, after very later, they found another method, a proper method. Rather than using fingers, stones or sticks, they found a proper method which we know as tally marks. This is a kind of a systematic way that the humans used to count. But why they moved from these methods to this one? Because when the values grew larger, they found out these methods are not going to be enough to count the values that they had. And when we say that it is not enough, we meant that they might had to collect all these number of stones in a heap to count. So it proven to be, all these methods were proven to be difficult to use. That is why they moved from these methods to a method like tally marks, where actually they can use easily. Hope you can remember what are tally marks. You might have learned this in your mathematics as well. If I show you as an example, there is a method that even in mathematics that you are using to count. Okay, the number that we are denoting by this might be 5 or something like that. Those are the tally marks that humans used initially during that time. But the humans' lives became complicated. They were so complex, and the things that they wanted to count also became more in the sense, actually the values grew larger. They wanted to count many things because they started collecting stuff, more and more stuff every day. So the values that they wanted to count also grew larger. Because of that, none of these methods were not going to be enough at the same time. So even they had problems with the tally marks because the numbers are larger. Now they have larger amounts to count. So whenever there was a large amount that they wanted to count and they cannot keep using the symbols, what they did was they introduced new symbols. It can be a new symbol like this to denote 100. It can be a new symbol like this to denote 1,000. Likewise, each and every day they had to add new symbols to this tally mark system. At the same time, what they did was they were repeatedly using the same symbol over and over again many times. And sometimes later on what they did was the symbols that they were using repeatedly, they even added them together to denote a large number along with the new symbol. So anyway, even after all that, these methods were proven to be not enough. Not enough in the sense when the list grew larger, it was very difficult even as a human to remember all that. So a layman cannot actually do the simple counting like they are doing it today because of the different various symbols that they had to remember. And whenever they had this large number of system and they were repeatedly using this number over and over again, after some time they actually, once after they have lost the track of it, they had to start counting from the beginning. So all these methods proven to be difficult. Because of that, what human did was they started finding a new method. So through civilization there was a new method they started to identify, and they brought this concept into the world, which we are going to learn now, which is they call as positional notation. Positional notation. This is a concept that they brought into the world. Once they have identified this positional notation concept, it was easy for them to find a systematic way to do the counting very easily, which is not going to be a cumbersome method like tally marks that they were using at the moment. So under this positional method, humans started to moving on to a number system which we call it as decimal number system. We call a decimal number system in the sense even in our day-to-day lives we are using a number system we call as decimal number system. So the decimal number system based on this positional number system, not only the decimal number system actually based on the positional number system, even the other number system that we are going to learn, that we are going to talk, is based on this positional notation. Now we will see what this positional notation has given to the humans when we compare this positional notation with the early counting methods. So I am going to do a kind of a small comparison. Here on this side I am going to talk about early counting methods. So I will take, as an example, I will take the tally mark system, because all the other methods they were not using them by the time that they were using tally mark system. So that is the example that I am taking under early counting methods, and on this side I am going to have positional notation. Systems such as decimal number systems that I have mentioned earlier. We are going to talk about decimal notation as well little later, but for the time being we will take it as an example only. So what was the significance? In early counting methods, they were repeatedly using the same symbol. This method, they were repeatedly using the same symbol, and every time they encounter a large amount, large value, introduced a new symbol. So that is what happened with the early counting systems. They were repeatedly using the same symbol. Every time they encounter a large value, new symbol was there. Because of that, the new symbol list grew larger with the early counting methods, and it was proven to be difficult to remember all these new symbols at the same time. In the decimal number system, what happened was they started reusing symbol. Actually, they started to reuse the same symbol. It is the same symbol again, but reuse of symbols after assigning a different value. Okay, I will write it first. After assigning a different value. To a position in a sequence. Here they reuse, it's true, it might be the same symbol again, but the specialty is they had a different value. Here we don't see that they were repeatedly using the same symbol over and over again. We don't see this different value, and that value actually based on a position in a sequence. The symbols are there in a sequence and they have a different position if it is in a sequence. For that particular position, they have given a different value. Because of that, whenever they were using the same symbol over and over again, they didn't have to go beyond a certain number of new symbols. So with this method, we will never run out of symbols, and we will have to remember only a limited number of symbols, sometimes maybe 2 symbols, maybe 4 symbols, maybe 8, or maybe 10 different symbols like that, which is not going to be cumbersome. That is why this positional notation was accepted by all of the people in that time, and they were even basing the other number systems on this positional notation. It was easy to use any number system given that those numbers, the symbols in a sequence have a different positional value. So let's see how these positional values have been changed in the way the humans do their day-to-day work. In decimal number system, the decimal number system is a number system based on this positional number system. So now hereafter we are not going to talk about any other number system or the counting methods that the humans were using like tally marks, because now the humans have found out, okay, there is a kind of a new way to count which is actually based on the positional notation, and that gave birth to decimal number system. As humans, we use it every day to do the simple counting or even to do any mathematical operations that we have to do. Now let's see how this decimal number system is actually working. Then it will be easy for us to understand the binary number system, because this number system is the language of the computers. This number system is also based on the positional notation, but that is mainly used by the computers, not us. So if we understand the positional notation through our language, which is decimal, it will be easy for us to understand somebody else's language. That is why we are going to understand the basic features about decimal number system using positional notation. Let me write a decimal number system over here, and as I told you earlier, this is based on positional notation. So if it is based on the positional notation, there should be a value given to the different numbers. We said that, okay, we are reusing the same symbol. If we are reusing the same symbol, we need to know what are those same symbols, how many of those are there. Decimal number system, it has a base of 10. we have given a value which we say, okay, the decimal number system, the number system that we use day to day in our day-to-day work, it has a base of 10. I'll tell you why the base is 10 little later. So whenever it has a base of 10, so now we need to understand what are those unique symbols, the different symbols, the limited number of symbols that we are reusing. So those we have just 10 unique symbols. We don't have any more. How many symbols are there? We said that even in tally marks, having to include all these new symbols to the system to count larger values is going to be cumbersome. Then we also have here reusable symbols. Then we need to know how many. If that was difficult, how many we will have to remember? Just 10 unique. Unique in the sense those 10 symbols are not equal. They are different to each other. So we have 10 unique symbols. Now the positional notations is the basis of this decimal number system. So there should be a value assigned to these symbols in a sequence. If these symbols are listed in a sequence, there should be a value given to that particular symbol based on the position. So that value, the values assigned to this base of 10 number systems are powers of 10. I will write it as values assigned. Values assigned to the positions by powers of 10. So the values assigned to these positions are changing by powers of 10. Because of that only we are saying that base is the 10, because all the difference between two values in a position is going to be a multiple of 10. Because of that we have given it as a base 10 number system, because of the positional, under the positional notations, the value that we have given to a specific position. Now I think you might have noticed a kind of a pattern over here. If the number system, that is decimal number system, you will have to remember the number system for that particular number system, which is decimal, and you need to understand, okay, decimal number system, deci. Even with the scientific measurements, you might have come across this name. If it is deci, actually that is meant by 10. By deci, a term, the number that we are going to represent is going to be 10. So if it is a decimal number system, that is going to be the base of 10. If you have a base of 10, the unique number of symbols that you have in that particular number system is going to be 10. And if you have unique 10 digits in that particular number system, and in that number system the base value is 10, then the values assigned to those positions are going to be differed by multiples of 10. So that is the pattern I am saying that you might have understood with this positional notation explanation of decimal number system. If the base value is 10, you have 10 unique symbols, and the powers are going to be like the difference of the powers, the positional values are going to be of powers of the same base 10. It is going to be, if it is 10, you are not going to get the values in multiples of 9s or 8s or 7s. If you are going to get the powers to the position in multiples of any other number, that particular number should be the base of that number. That is why positional notation is going to be really simple and easy to understand. When you have just unique symbols, 10 unique symbols, what are those 10 unique symbols that you have come across in your mathematics even? Those are, 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Those are the 10 different digits that we are using inside the decimal number system. And in your experience, you might have used these numbers over and over again, but based on the position of their numbers, you know that their values are different. We are going to talk about that little later. Now, since we have understood this notation with the decimal number system, which is you and I, my language, I'm going to move into the binary number system, which is the computer's language, to talk about the same notation in there. It will be easy for you to understand now once you have understood decimal number system properly. So, if it is the binary number system, as the name says it, we need to understand what is the base. Why? The number of unique digits, the powers, the value that is going to get to the position is going to be differed by the based on the base value. Because of that, when the name is given for a particular number system, it is important for us to understand the base value of that particular number system first. So if it is binary, like deci, bi means 2. So it is a base 2 number system. Now our work is so much easier. Why? We have understood what is the base of that particular number system, and it is going to have the same pattern that we identified in decimal number system. Hope you can remember that pattern. It is going to be 2 unique symbols. If it is base 2, 2 unique symbols. What are those 2 unique symbols or the digits? That is going to be either 1 or 0, because we just have 2, so those 2 are going to be either 0 or 1. Then what is the other one? Values of the positions differ by powers of 2. Why 2? Because the base value is 2. That is the pattern that we have understood with the decimal number system. So it is going to get repeated in the other number system as well. That is why I told you it doesn't matter what is the number system is. If you have identified the base value properly, you can understand how many unique symbols are there and how these values are going to get differed from each positions, because everything is based on that base value. So we humans are do the talking using decimal numbers. If humans are the people, the ones that who are making those computers, why don't we use decimal number system in making of a computer? That's a problem, right? Why are we using this just 2 symbols to represent any language, any symbol, any number? They are in that particular machine. That is your problem. Why? Because the computer is made out of millions of switches. Whenever it is made out of millions of switches, they have only 2 states. If it is a switch, you know that you can either put the switch on or you can put the switch off. It is the similar with the switches inside the computer as well. So they have only 2 states. To identify those 2 states, why use of 10 different symbols? That is why they thought of actually using binary number system, which actually has made the whole process very simple. So they were using this because on state inside a computer, on state can be identified as 1. If it is identified as by 1, then the off state can be identified from 0. So using this method inside a computer, they have created a method where any value can be represented. We are going to talk about that again little later by familiarizing with the binary number system and decimal number system more and more. So for the time being, we'll see how we can use these two different methods in our day-to-day lives, because decimal number system we are using in our day-to-day counting as well. So let's move on to the next video to see how we can understand those two different number systems properly.